Ever wondered if you could zip back to the past or leap into the future at will? This question has been stirring minds and sparking imaginations for centuries. From H.G. Wells's The Time Machine to the iconic Doctor Who series, the idea of time travel has been a captivating staple in popular culture and literature. Time travel, in essence, is the theoretical journey between distinct points in time, akin to how we move from point A to point B in space. It's a concept that challenges our understanding of reality and the universe, a concept that blends the realms of science, fantasy, and philosophy. The allure of time travel is undeniable. The idea that one could revisit history, correct past mistakes, or witness the evolution of mankind is certainly enticing. Yet as riveting as it may be, it's not as straightforward as jumping into a time-traveling DeLorean. But as tantalizing as it sounds, time travel isn't as simple as hopping into a DeLorean. So what exactly is time travel? Well, at its core, time travel is the concept of movement between certain points in time, analogous to movement between different points in space, either sending objects or information backward in time to some moment before the present, or sending it forward from the present into the future without the need to experience every intervening period. Now imagine time not just as a linear progression of events, but as a fabric. This is what we call spacetime, a four-dimensional fabric where everything that has happened is happening and will happen exists simultaneously. To better visualize this, consider a sheet of paper. On one side of the paper we have the past, the other side represents the future, and the thin edge in between is the present moment. Now if we could somehow fold this paper, bringing the past and future closer together, we could, in theory, step from one to the other, skipping the space in between. This is the essence of time travel. There are a few theories that propose how we might accomplish this. One popular one involves wormholes. Wormholes are hypothetical features of space-time that essentially act as shortcuts through space and time. If they exist and if we could harness them, they could potentially allow us to travel vast distances in the blink of an eye, or even move backward or forward in time. Then there's time dilation, a concept derived from Einstein's theory of relativity. The idea is that time passes at different rates for people who are moving relative to one another. An astronaut traveling at near light speed on a space mission, for instance, would age less than those who remained on Earth. In a sense, they would have traveled into the future. But remember, these are just theories. While they're backed by a significant amount of mathematical and scientific evidence, we've yet to observe or experimentally confirm these phenomena in a way that would make time travel a reality. The concept of time travel is fascinating, but it's not without its share of problems. Why is time travel so problematic? That's a question that has puzzled scientists and philosophers alike. Let's dive into the deep end and examine the paradoxes and problems associated with time travel. Firstly, we grapple with logical conundrums, the most famous of which is the grandfather paradox. Imagine, if you will, a time traveler journeying back into the past and accidentally causing the death of his own grandfather before the conception of his father or mother. This would result in the time traveler never being born. But if he was never born, then how could he have traveled back in time in the first place? It's a circular argument that seems to defy logic, and yet it's an inherent problem in the concept of time travel. Similarly, we have the bootstrap paradox, another head-scratcher. This paradox is named after the phrase, pulling yourself up by your bootstraps. It involves an item or information that is sent back in time, becoming the source of the same item or information in the future. In essence, it has no origin, it simply exists, looping infinitely through time. If you've ever heard of the chicken and the egg problem, this is the temporal version of that. Moving on from logical problems, let's talk about the physical challenges. Time travel, as per our current understanding of physics, would require the existence of negative energy. But here's the kicker. We haven't found any concrete evidence of negative energy yet. It remains a purely theoretical concept. Lastly, there's the potential for catastrophic events. If time travel were possible, any alteration to the past, even the most minute, could drastically change the present. It's the butterfly effect on a cosmic scale. One misstep, and we could be looking at an entirely different universe. Despite these problems, the allure of time travel persists. It's a testament to human curiosity and our relentless pursuit of the unknown. No matter how many paradoxes we encounter, no matter how many problems we face, the concept of time travel continues to captivate us, beckoning us towards a future where the constraints of time might just be another boundary we learn to cross. So, can we actually travel through time? This is a question that has been posed by many, from curious children to the most brilliant minds in the scientific community. And the answer, while not quite straightforward, is a tentative yes. The current scientific consensus on time travel is largely based on Einstein's theory of relativity. This theory suggests that time and space are intertwined in a four-dimensional fabric known as spacetime. The fascinating bit is that this fabric can be warped and twisted by gravity, causing time to slow down or speed up. This phenomenon, known as time dilation, is effectively a form of time travel to the future. In fact, astronauts aboard the International Space Station experience this firsthand, albeit on a very minuscule scale. They age a fraction of a second less than those of us on Earth due to the slightly slower passage of time caused by the gravity of our planet. However, traveling back in time is a whole different ballgame. Some theories suggest that wormholes, hypothetical shortcuts through space-time, could potentially allow for backward time travel. But the existence of such wormholes is purely speculative, and even if they do exist, they are expected to be highly unstable, collapsing instantaneously. Despite these challenges, time travel remains a popular field of theoretical research. Scientists and theorists are continually pushing the boundaries, exploring concepts like quantum mechanics and parallel universes in their quest to unravel the mysteries of time travel. But as of now, the reality is that we do not have the technology or understanding to make time travel more than a theoretical possibility. Yet the many paradoxes and problems associated with time travel do not dampen our fascination with it. On the contrary, they fuel our curiosity, encouraging us to continue to explore, to question, and to dream. Time travel, while fraught with problems, continues to captivate us, urging us to explore the boundaries of what's possible.